In this video, we're going to talk about Venn diagrams. There are a couple of videos on it already, but this one's going to be a little bit different. In this problem, we're going to introduce Venn diagrams where there's going to be uncertainty in it, where we're not going to be able to place numbers specifically like we have been doing in the previous ones. So let's take a look at this example. We find that 25 people enjoy running and 45 people enjoy biking. The question is, how many people enjoy both? And I forgot to mention, but it is out of 100 people. So you surveyed 100 people, this is what you find. Now, how many people enjoy both? We're looking for this region right here. Now, the only way we were able to fill out the Venn diagram before was that I needed to know a number that went into one of these regions. Okay, there are 4 regions, specific regions, and I needed to know at least one of them. But the problem here is that we don't. So let's say this circle here is running, and then we can say this one is biking. All we know is that the running people will have 25, meaning if I add these 2 regions together, I should add up to 25. And with biking, I know I have to add up to 45, which, again, these 2 add up to 45. So you might think, wait, there might be a way, you start guessing and you're like, okay, maybe 10 goes here and then 15 here and 35. Well, hey, look, that worked, right? 25 and 45. Well, okay, well, how about this? 0, 45, and 25. Does that work? Yeah, it does. So the problem with this is that if you don't know a number in one of these specific regions, there's going to be some uncertainty. We're going to be able to find the answer is going to be a range of people. So guessing is not the greatest way of going about this. So let's erase, and I'll show you a better way. I think the easiest way of going about this is to see if you can put a 0 here. Okay, since 0 goes here, then 25 would have to go here, and 45 would go here. And so you'd add these up, 25, 0, and 45. And this adds up to 70. Now, if there's 70 in these circles, and you asked 100 people, that means there has to be 30 on the outside. So here's one possibility, and it worked. So always start with 0. And then I'll do an example where when you start with 0, it doesn't work. But let's stick with this first. Okay, well then you can say, okay, well how about 1? And that would have to be 44, and this would have to be 24. It all works out. And then on the outside, we need 31. And then you can do 2, and this would be 43, and this would be 23. And then out here would be 30. Oh, sorry. 32. Okay, so you can see how this is going to work. So how far am I going to be able to go up with this? Because, you're not going to want to do 3, 4, 5. I mean, we want a better way. So can you kind of see how many we can go up to? Well, since this circle must add up to 25, the highest that this can go is 25. Can't go more than 25 because then it violates that number here. So if this is 25, this must be 0, and then this has to be 20, which makes out here 55. And again, you can't go above 25 because, again, it violates our condition that 25 people enjoy running. And that's it. So our answer, how many people enjoy both, the answer is between 0 and 25. Or you can say less than 26 or less than or equal to 25. Okay, something like that. But there you go. So let's try another example. Okay, let's begin our next example. So out of 100 people, you find that 62 enjoy running, 58 enjoy biking. So how many people enjoy neither activity? Neither activity would be the people that are outside the 2 circles. And then also a follow-up question, how many enjoy only running? Okay, so we have I think we said this was our running circle and this biking circle. All right, so what I'm going to do is I want to try to put 0 here. All right, now let me label these. So 62 and 58. Okay, so if you put 0 here, that would mean that this is a 62. This would have to be a 58. Now the people on the outside would be the ones left over. So if you were to put 62 and 58 into the calculator, you find out that these numbers together add up to 120. We don't have 120 people. We only have 100 people. So then you might ask, okay, then what's going on? Why are we getting more than 100? Well, that means you're counting people twice. So it is not possible for 0 to be in this region because these are the people who get counted twice, and we went over. Now, how many people got counted twice? Exactly the difference between this number and how many people you're supposed to have. Because when you add up these circles, you can't add up to more than 100. So, how many people did we go over by? Exactly 20. So that's where we start in the overlap, or in the intersection. Okay, so we're going to put a 20 here. And then it follows the same rules, or the kind of the same method we did in the last example, where say, okay, if this is 20, then this is going to have to be 42, and then this is going to have to be 38. So how many people are on the outside? Well, if you add up these three regions, they add up to 100, which means no one's on the outside. And then this can go up to 21, so that makes this 41. Oops, sorry. And then this would be 37. And then on the outside, when you add up these three regions, you'll get 99, which means there's one person on the outside. And you would keep doing this, and you'd go up to however, pretty much the smaller of these two numbers, okay, which happens to be 58. So that would mean that 0 is in here, and 4 would be in here, because then 4 plus 58 is 62. And then this region, these two together, add up to 58. So how many are on the outside? That would be 38. Okay, so now we've figured out what each region could be. Let's go ahead and answer the question. So how many people enjoy neither activity? So this is the neither activity. Just say neither. So you can say between 0 and 38. And then the follow-up question was how many people enjoy running? Well, these are the people who only enjoy running, because again, we're saying only, which tells us they can't be in the overlap. They have to be here. So these are the people who enjoy only running. And so your answer would be between 4 and 42.